Tonight we're going to be going over geometry formulas, and we're going to do this in two parts. We're going to start today with part one, and I hope you will join us for the exciting conclusion next week in part two. This is studyhall.testive.com. If you ever need to get back, we do this every Monday, 9 p.m. Eastern or 6 p.m. Pacific. And everybody else, you have to interpolate. I'm the real Tom Rose. I'm one of the co-founders of Testive, the company that is putting together Study Hall for you guys. I'm a professional teacher, and I help build all of the curriculum content at Testive. Some people call me a square, but I really like to think of myself more as a rhombus. That's a little bit about me. So where are we at geometry-wise? Couple interesting facts about geometry. First of all, it's 31% of all math questions. It is the second most common type of math question, so you definitely want to take some time to make sure that geometry is clicking and firing for you. It's the most esoteric category of math question, I think, meaning they ask you about things that are quite strange, right? So I think of the list of geometry formulas that the SAT expects you to know to be kind of unusual, right? So like, why, for example, do they expect you to know 30, 60, 90 triangles, but they don't expect you to know some other measure of triangle? Where did they come up with that? And the answer is that it's somewhat arbitrary. So the list of things that you need to know is a subset of the interesting things that are out there in the world, and you need to know the right subset of things. So a big part of being good at geometry is really just making sure that you have memorized and learned and understand the same list of things that the SAT expects you to know. And the good news is, spoiler alert, it's not that long of a list, which is great. It is the fastest question type for math improvement in my experience as a teacher. So if you are trying to improve your score dramatically in any one particular area, math in particular is geometry in particular is going to be one of the most satisfying areas for you to prep. So how do you get better in geometry? Two big things for you to do. Number one, build your own cheat sheet. This is by far the most important thing for you to do. And by cheat sheet, what I mean is a single 8.5 by 11 sheet of paper that contains the set of rules and formulas that you need to be getting better at. So you don't need to put everything that you need to know on there. That would be too much. But what I would do is I would simply put the things on there that you need to know cold, but you don't right now. So and that's why everybody has to do it for themselves. I can't just give you a cheat sheet because your cheat sheet is going to be different from your neighbor. So put together that cheat sheet, and it's not going to take you very long. You can build it. So we're going to do geometry in two parts. You can build half of your cheat sheet today, half of your cheat sheet next Monday, and really you can get the whole thing done just while you're watching the sessions today. Two, memorize the formulas. So once you put those things on your cheat sheet, the next thing you need to do to get better at geometry is memorize that stuff. So we call it a cheat sheet because you're going to use it while you're doing SAT prep at home by yourself. But the objective is to get all that information to soak into you so that you don't need that sheet anymore. So you just use it as a crutch until you're able to walk and run without it. Say cheat sheet 10 times fast. Cheat sheet, 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 cheat sheet. That sounded like a different language. That was a chat window question, which is a good reminder. If you guys have questions, go ahead and post them in the chat window, and I'll try to get to as many of them as possible. The chat window itself is not actually that tall, so I apologize if I miss your question. If I do miss it, please just send it in again. God forbid I should miss something that is important to your learning. So if that happens, please alert me because it was an error and I'd like to rectify it. Okay, geometry process. It's basically a straightforward three-step process that you can apply to all geometry questions. And this is one of the reasons why geometry is one of the fastest areas for people to improve, because you can apply the same process to every question. The first step, number one, complete the picture. So every geometry question should be basically a visual puzzle that you're trying to solve. It is very common on the SAT for them to give you a picture and for them to then accompany that picture with some text, which is not duplicated in the picture, but the text is relevant to the picture. So they might give you a picture of an angle or a triangle, and they might say angle A measures 36 degrees. Well, it's really important for you to actually take the 36 and label it on the picture. So whatever's missing, whatever extra stuff they give you, make sure that you use it to complete the picture, right? If you're not doing this step, it's definitely going to hold you back, and you're definitely leaving points on the table. It is a very commonly overlooked thing because it sounds very pedestrian, but it's super important. Make sure you get all that information out there. Step 2, consult the relevant formulas. So in the short term, you'll be consulting your cheat sheet for relevant formulas. In the long term, you should be basically going through the compendium that you've downloaded to yourself, that you have memorized. And step 3, solve the puzzle. So once you've got your visual complete, you've consulted the relevant formulas, all that should remain is you using the information you've been given, a set of formulas that you're adding to get to some unknown quantity, and you can solve that puzzle. So let me take some questions in the chat window. Are there any other ways to memorize formulas than basic memorization? Sure. A couple of people have been very successful with flashcards in geometry. Another thing that some people like to do is make mnemonic devices or helpful little memory techniques. So if you were here for the idiom day, for example, I had a memory technique called a big fart odor with tuna. Does anybody remember what that stood for? A big fart odor with tuna. That was a memory technique for remembering these 6 nonsense prepositions. I'm not going to go through all of them in here, but they are, they start with the first letter of each word. So A was as, big was by. So you can use techniques like that to help remember. In geometry in particular, I've actually found that just basic rote flashcard memorization is actually the fastest. One of the takeaways from today, and one of the things you'll learn when you start making your cheat sheet, is actually the list of things you need to memorize is surprisingly small. And one of the things that stops people from becoming better at geometry is the perceived amount and the perceived length of this is very high. When you start, you'll actually discover that it's not that high. And you could probably, without any special techniques, just simply write it out and then memorize it. Yes, and that's a great point, Jordan. Geometry is nice because there's no negative or imaginary numbers. Will we be going over some problems? Yes, I have a couple that I've written for you today. So let's jump into it. Fevin, nice. You got the a big fart odor with tuna. You have all of them, all the letters. Great example that mnemonic device works. So you guys can make those for geometry if you like. Now, let me start by giving you some geometry dangers, things that will prevent you from being successful in geometry. The first is incomplete learning. So you may have experienced this already if you don't feel that you've exhaustively memorized all the formulas that you need. Because incomplete learning leads to uncertainty, because you'll be on a geometry problem and maybe you're not sure how to solve it, and you don't know whether you're unable to solve it because you haven't figured it out, or whether you're unable to solve it because there's something that you're supposed to have memorized that you actually don't. And since you're not able to tell the difference between those two situations, it leads to a lot of time wasting. So it's very important for you to, again, memorize those formulas, hence the cheat sheet. And if you're not catching on to the pattern by now, it basically goes down to cheat sheet, memorize, and that is the way forward in geometry. Don't be afraid; it's a short list. The second geometry danger is thinking. Thinking, of course, is necessary to figuring things out, but what you want to do is keep all that thinking time to a minimum. And again, thinking can lead to time wasting. So what you want to do is try to get your thoughts out on paper, and you want to have those formulas top of mind, meaning you don't just know the formula, but you know the formula quickly and you know it very concretely. So there's no doubt in your mind. You don't have to spend time deriving it. You just know it, boom, you deploy it, it's fast. All of this is going to lead to a faster performance on the SAT, which is going to lead to higher scores. Conclusion, make sure you know your formulas. That's what's going to set you free in geometry. So on your cheat sheet, how should you do it? Well, log anything that you see that you don't know cold. And I would start doing this. If you don't have it yet, I would get an 8.5 by 11 sheet of paper and something to write with, ideally a pencil so you can erase. And anything that you see that comes up in the next 15 minutes, If you don't know it cold, put it down on that sheet. Write clearly, but a little small so you have room on your paper to fit everything. And I bet you're going to be able to get everything on a single side of that 8.5 by 11 sheet of paper, even if you do today and next week, which will give you the full geometry set. Worst case scenario, you're going to have to do front and back. So here we go. In the next 15 minutes, we're going to go over half of all the formulas, and then next week we're going to go over the other half. First, some notation. It's very helpful to be able to understand geometry notation for a couple of common things. For example, lines of equal length you can identify using these hash marks. Right? So this hash mark right here and this one right here, you can use those to indicate lines of equal length. By the way, anytime if you have multiple lines and you need to double up, you can also do that. Right? So what you could do in that first line, it's not so great. But what you can do is you can double up on these if you had two lines and you wanted to distinguish. Say these two are the same length, and then there's these other two that are the same length, and maybe they have single hashes. Angles of equal measure get arcs. So here you've got your arc and your other arc, and they're both single arcs, which would tell you that those angles have the same measure. And lastly, for notation, you've got parallel lines. Parallel lines have these little fletchings. They look like fletchings from an arrow. And that's what you can put on here to indicate parallel lines. You should find yourself using these pieces of notation a lot. So you should definitely never go through a full SAT without using all three of these. Next, vertical angles and supplementary angles. So here we've got what we have is a system of lines. So this is two straight lines that intersect in a point. And anytime you have two lines intersecting at a point, it creates four angles. And we're going to letter those A, B, C, and D. And notice that I've used this angle notation to indicate which angles have equal measure. So the first thing you can see is that opposite angles, so B and D have the same measure, and A and C have the same measure. And that'll always be true for systems of lines. So I call these opposite angles. Some people call these vertical angles. Have equal measure. Now, there's also another thing on this picture that you can take to heart, which is called supplementary angles. Supplementary angles sum to equal 180 degrees. Now, you don't really need to memorize terminology. So vertical angles, you don't need to know that word. Supplementary angles, you don't need to know that word. What you do need to know is the concept. So you need to know that across any line, so notice we have a line right here, and angles A and B together add up to that whole line. So between angle A and angle B, you get from one side of the line all the way back to it. Those two angles then will add up to 180. So even though I just put on here A plus B equals 180, you could actually do this 4 times. You could say B plus C equals 180. You could say C plus D equals 180, or D plus A equals 180. So here's a question for you. And when you get the answer, do not type it in the chat window. What I'd like you to do is actually type it in the chat window, but do not press enter. So you should just have the answer sitting in that text box, but not sent to the group. And I'm going to give you a couple seconds to complete this. And then we're all going to do it together at the same time. So figure out what B is equal to. Type that into the text box in the chat window, but don't send it. And while you're doing that, I'm going to answer a question in the chat window. Samir is asking, do all of these notations appear often on the SAT? Samir, the SAT actually does not assume that you know these notations. Those are notations that are really useful for you to use to label the drawing. And the SAT will tell you explicitly. They'll say, line XY, line segment XY is the same length as line segment WZ. And when they tell you that, you should then take that information and label your drawing by putting the hash marks. So you should be using them a lot, but the test will actually not use them. Okay, so go ahead and send your answers in now. Yes, and we're getting a lot of correct answers here. So this is 45 degrees. And how did you know that? Well, write it out here quick. We know that A plus B equals 180. That's the rule that we just learned. A is 135. So we can make an equation here. You probably didn't need to even write this out, but if you ever do have something more complicated, you can do this. I write it out algebraically, and then you can solve for B equals 45. Okay, let's keep rolling. How about another one? Again, when you figure this one out, type it in, but don't send it to the group. This one should be a little bit faster. Okay, and go ahead and send your answers in. Yes, this is 135. And how do you know? There's nothing to calculate, actually. You just need to know that vertical or opposite angles have the same measures. So C is equal to 135. Great, you guys are doing well. On to a parallel line system. So the test loves to use these, absolutely loves it. And what they're going to do is they'll give you two lines. And notice that I've got the parallel line fletchings here. That the test wouldn't give you these again. They would tell you these are parallel, but you would draw these on. So I know we have two parallel lines here. And you'll notice that there's a third line, which some people call a transversal. Again, you don't need to remember that. But the transversal is cutting through and it's intersecting both of the parallel lines. And you'll notice that 8 different angles are created, A, B, C, and D in the first system, and then you've got E, F, G, and H in the second system. And so what is it that you learn from a parallel line system? Well, we already know that A and C are equal, B and D are equal. We already know that E and G are equal and F and H, and those you see all those labeled. The new thing is the concept of corresponding angles. So a corresponding angle is another way of saying, in the case of A, for example, A is sort of the top right angle in the upper system here. Well, down here on the bottom system, the upper right angle, E, is A's corresponding angle. It's the angle that's in the same spot physically in the other system. Those angles have the same measure. So you see that A is equal to E. But since C and G are the opposite angles, those are also equal. So what you'll find is that you actually have 4 angles that all have the same measure, A, C, E, and G. And the other set also has the same measure. So you've got D, B, H, and F all have the same measure. So here's a question for you to answer as soon as you figure it out. How many numbers do I have to give you when it comes to angle measure so that you can generate all 8 angle measures? How many different numbers do you have to be given to figure out all 8? Yes, it is just 1. It is not 2, but just 1. Because if I give you A, you can figure out B, because you know that A and B sum to give you 180. And once you have A and B, then you have everything, because of course you can come down here and you can see that A gives you C, E, and G, and B gives you D, H, and F. So this is why this, in case have you ever wondered, why does this weird situation with the parallel lines of the transversal, why does that show up on the SATs so often? And the reason is because they can give you very small amounts of information, just one number, and you can generate 8 angles off of it. So it allows them to give you what appears to be insufficient information, but if you're clever, it will allow you to solve the whole system. So here, solve this one. Again, type your answer in, but don't send it. Okay, go ahead and send your answers in. What is angle E? Of course, it's the same as A. Nothing to calculate because they're corresponding angles. So E equals 125. Here's one that's a little bit more complicated. What is the angle of F? And Go ahead and send it in. Yes, it is 55 degrees. And how do we figure that out? Well, here we have a corresponding angle, 125. And then we know that 125 plus f equals 180. So you can solve for f equals 55 degrees. Great. Keep moving. A couple of triangles the test will expect you to know. Equilateral and isosceles. This is an equilateral triangle named because the sides are all the same length. Right? And notice I've got the hash mark, the single hash mark, to indicate that all three sides have the same length. Equilateral triangles also have all three angles the same measure. Not only are they all the same measure, but they're all always the same number. They're all always 60 degrees. So equilateral triangles are very, very well-known shape. As soon as you figure out it's equilateral, not only do you know the sides are all the same, but you know all the angles, and you know the angles all measure 60. Similar, but not exactly the same, we have the isosceles triangle. The most commonly misspelled types of triangles. Isosceles triangles are defined by having two sides that are the same length. So not all three, but just two. And you'll notice in this picture that I've indicated that this side and this side have the same measure, but not the third side. The third side is noticeably shorter. And what the test will expect you to take away from an isosceles triangle typically is that the angles have the same measure. So once you know those two sides have the same measure, it is the two angles opposite those sides that have the same measure. So A is equal to B. And sometimes it'll go the other direction. So if you have two angles that are the same measure, you can infer that the sides are the same. If the sides are the same, you infer the angles are the same. Now, some of you are predicting my next question, actually. So hang in there. We're about to get to that. One more thing first, which is triangle angles sum to 180 degrees. I'll fill in all the little degree bubbles that should be in here. So here's a triangle down below. We've got three angles, A, B, and C. If you add up those three angles, A, B, and C, they will always equal 180 if you are in fact dealing with a true triangle. So let's put that together now and see if you can solve this one. So what is the measure of angle C? Just calculate it, but don't send it in. Okay, and go ahead and send in your answers. Okay, we're getting 140s. So what do you have to do to solve this one? Now we're starting to get to the level of problem that you would find on the SAT. So we have, notice we've got two sides that are the same length. So this is an isosceles triangle. So which means these two angles are the same measure. So we've got that one and this one. And the first one is 20, so the second one is 20. And of course, with triangles, the sum of the angles equal 180. So we'll have 20 plus 20 plus C equals 180, which will give you 40 plus C equals 180, or C equals 140. And who was it in the chat window? It was Kev, who typed the generic formula for the number of degree measure in a polygon, which is the number of sides minus 2 times 180. So if you want that one, you can add it as well. That's not one that I keep on my cheat sheet because it doesn't really come up on the SAT, but that is a helpful thing to know. Thank you, Kev. So let's talk right angles. If you have a triangle and one of the angles in that triangle is a right angle meaning 90 degrees, here's the notation for a right angle. It is a square, which you'll see in the corner there. So this would indicate a 90-degree angle. Then that triangle will be what's known as a right triangle. Right? If you have a 90-degree angle in your triangle, it is a right triangle. Right triangles have some special properties. In particular, they conform to a special rule governing the lengths of their sides, and you can calculate the lengths of the sides using what's known as the Pythagorean theorem, one of the oldest and most useful geometric formulas of all time. So the test is definitely going to expect you to know it. And the way that the theorem goes is the following. You have three sides labeled A, B, and C. C, by convention, is always the longest one, and that's important for the formula. You have short side squared plus the other short side squared equals the long side squared, or what most people memorize, A squared plus B squared equals C squared. It's almost a guarantee that this is going to be on your test. It's that common. Here's an example. Go ahead and calculate value of A here using the Pythagorean theorem. While you do that, I'm going to answer a couple of questions in the chat window. Sammer, is there a postulate that says that the hypotenuse must be longer than the sum of both sides? It's actually, that's close. What it is the hypotenuse must be shorter than the sum of both sides. And there's a formula, or a theorem people typically call the triangle inequality, which is the hypotenuse must be less than the sum of both sides, which we will cover. We will cover next time. There's also another inequality, which the hypotenuse must be longer than the difference, or any side must be longer than the difference of the other two sides. Okay, if you have an answer, go ahead and send it in. The answer here was 5. A equals 5. And how do you calculate that? Well, let's do Pythagorean theorem, which is A squared plus B squared equals C squared. And we'll have A squared plus B is 12 squared equals C is 13 squared. So what you end up with is A squared plus 144 equals 169, or A squared equals 25, or A equals 5. Take the square root of both sides. Now that may seem like a lot of work, and it is a lot of work when you consider that you could have simply memorized this, and Alexander is suggesting that there is a shortcut here, which is what he would call a Pythagorean triple, and that's exactly what they're called. And many of these solved by the mathematician Euclid. There are a whole bunch of, in fact, I think Euclid proved that there's infinite Pythagorean triples. There's an infinite number of whole numbered sides. So this is one of them, 5, 12, 13, that people commonly memorize. So, and there's a handful that it would be useful for you to memorize for the SAT. And here's the list that I suggest that you commit to memory. It is the most common one is 3, 4, 5. I would also memorize several multiples of 3, 4, 5. So 6, 8, 10, 30, 40, 50. And the test will expect you to recognize several multiples of 3, 4, 5. So if you think you might be dealing with a triple, check to see whether it's a multiple of 3, 4, 5. You can multiply 3, 4, 5 by any integer n to get another one. So if n is 2, you get 6, 8, 10. If n is 3, you get 9, 12, 15, for example. So you want to catch those. And then there's one more that I like to add, which is the 5, 12, 13. And that's my personal list of what I have memorized. Alexander, let me know if that did not answer your question about the triples. But this is literally the list that I have these 4 in my head. Last but not least, in the first part of geometry, I want to cover the distance formula. The distance formula, which we have right here, may look to you at first as though it is one of the most complicated formulas that we're measuring, that we're learning today. But in reality, it is only slightly more complicated than the Pythagorean theorem, and that's what I want to show you right now. So let's say that you have a line, and I have a coordinate plane down here with a line, and the test wants you to calculate the length of that line. And this is all that you're given. So you know the line starts at the coordinate 1, 1, and you know that it ends at the coordinate 4, 5. You write those in here. So this is 1, 1, and it goes to the coordinate 4, 5. That's the start and end of that line. But what you really want to know is the length of that line. Well, here's how you do it. What you do is you draw an imaginary vertical line dropping straight down, and you draw an imaginary horizontal line cutting straight over. And what you create is a triangle. And not only do you create a triangle, but because you drew your line straight down and straight over, you've actually created a right triangle. Right? So now that you have a right triangle and you know the coordinates, you can calculate the length of the distance between these 2 points, because that distance is the hypotenuse of this triangle C. So let's label these sides. Let's label the 2 small ones A and B, and the hypotenuse C. And I'm going to write that down here, and you can see that, let's put it in this format, C equals C squared equals A squared plus B squared. And then I want to plug in a couple of things. So what is A? How do you calculate A on this particular coordinate system? Well, A, you can't just read it right off of there. You have to look at the x-coordinates of the first point and the x-coordinate of the second point. So A starts at the x-coordinate 1, and it ends at the x-coordinate 4. So let's call the second point x2, and we'll plug that in here. So we'll have 4 minus 1. And that's your A. Now we want to calculate B. Well, B starts from right here, the 1, and it goes up to the 5. Let me label these as I'm doing it. Call this x1 and this x2. And we'll call this y1 and y2. And so we start out, y2 now is 5. And let's subtract y1, which is 1. And then square that. And let me just translate this now. What you'll see is that we've got x2 minus x1 squared plus y2 minus y1 squared. All of that equals c squared. Now, right now, this should be looking pretty familiar. I basically started deriving the distance formula. And notice that the formula that I've come up with here is almost exactly the same as the distance formula, with one little difference. We have c squared instead of d, and this part on the right does not have a radical. It doesn't have the square root. Well, we can fix it by taking the square root of both sides, and what you end up with is c equals, the hypotenuse equals x2 minus x1 squared plus y2 minus y1 squared, all underneath that radical. And that's where the distance formula comes from. It's really just the Pythagorean theorem. And they call c d for distance. So there you go. If you memorize the Pythagorean theorem and you can read a coordinate system, you actually don't need to memorize the distance formula, as complicated as it looks. Now, if you do memorize it, it can make you a little bit faster on the test. But if you have trouble remembering, you can always use that Pythagorean theorem. So what was the answer? Does anybody have the answer? Go ahead and send it in the chat window. You got it. The answer is 5. And you can do that a couple of different ways. Notice that A has a measure of 3 and B has a measure of 4. So this is actually a 3, 4, 5 triangle. So C equals 5, which means D equals 5. Or you could solve the equation that you had right here. Right? So you get 3 squared is 9, plus 4 squared is 16, which would equal 25. You take the square root of that, and you will get 5. So there you go. That's the distance formula, and that's a typical SAT question that you'll see there, is using the distance formula to calculate a number like that. We will go over how to find areas of more complex figures in the next study hall. Somebody also asked another question about what else we would go over. So we're going to go over everything that would be on a geometry cheat sheet. It is the entire list of formulas that you need to know for the test. So between today and then next week, we will have covered it all. If you'd like to do further practice, particularly in geometry, you can do that at www.testiv.com, and or you could work with a 99 percentile scoring coach. I'd like to acknowledge all the people that helped put this together: Miro Kaz, Harvard, Pikachu, the chemist, the closer, Brazil, Chubby Shorts, Kitten Smuggler, the Saint, and Will, the Institute Eaton. It takes a lot of work to put these together. You've been watching studyhall.testiv.com. I'm the real Tom Rose, and thank you so much for coming. Before you take off, please help us by filling out some of our surveys that we're putting up on the screen. Love to hear positive feedback, negative feedback. Love to hear what you'd like to see in the next study hall. Also tell us how likely you are to refer this to a friend so we know whether we're doing a good job. Up on the screen, you can also see a bunch of other Testiv resources that you can access. You can get a personal 99 percentile scoring coach. You can get a free 30-minute practice test. You can answer more practice questions. You can answer them by category if you'd like to just do geometry. Of course, there's studyhall.testiv.com, and you can also, if you have Blue Book tests that you've answered from the College Board official study guide, you can put your answers in at Testiv, and we will analyze those, and we will send you your strengths and weaknesses, and we'll do that all in real time. So thank you guys so much for coming. Let us know how we can make this better for you. I hope to see you next week, Monday, 9 o'clock Eastern. If you have lingering questions, feel free to type those in the chat window. I'll try to get as many as I can.